This is Unit 5, Investigation 1, Lesson 1. We're going to be exploring rational functions today. In the red box, you're going to see the form that we have this function in. F of x is equal to 1 over x is the parent function, which is the general format of any rational function. Think about that a over b, it's always in quotient form. So this form might be similar to something we've seen when we did vertex form of a quadratic or absolute value function. So you can recognize that the hk, that coordinate, would be the vertex of whatever function you were working with. So these a, h, and k values are asking us, okay, well, how will they impact the graph? Well, if we used the absolute value function, let's just go with that one. So if we have the absolute value of x, this is the parent function for absolute value. So if we have that, and then we add a number, we have x minus 5 in our absolute value brackets. So if we do that, and we add this graph, you'll notice that the vertex goes from 0, 0 to 5, 0. If I had plus 5 here, you'll notice that it actually shifts left 5 directions. So this is our left or right shift from our h value. Then if we graph the absolute value of x minus 5 plus 6 and compare that to both graphs, we'll see that from this red line to this blue line, all we did was we added 6 to our function. But as you can see, not only was this light blue line shifted right 5 units, but it was also shifted up 6 units. So here, if that k value shifts up, then if I have minus k here, or minus 6, then it'd be shifted down 6 units. Lastly, I'm looking at y is equal to 3 times the absolute value of x minus 5 plus 6. So if you can look at that graph in green, you will see that compared to this blue line, this green line is way steeper. So it's very similar function, except now that we have that coefficient in front of that absolute value function, then we have an a value that's greater than 1, right? So the a value, if you raise the a value, the steepness increases or the slope increases. Or if you lower the a value, then the steepness or the slope decreases. Okay? For number 2, you're going to tell me how a, h, and k will have similar effects on the graph of a rational function and explain how that might be the case. This should be 3. We know a rational function is in the form of a quotient. Whenever you hear the word quotient, I need you to think division, as with fractions, which are always in a over b form, right? And that's also division, even though it's a fraction form, it's still a quotient, right? It's a division of 2 integers. So if we go to a rational number definition, a rational number is a quotient where a over b, a and b are integers and b cannot equal 0. So the denominator b cannot equal 0. So we have to zero in more on this aspect, because then that will give me an undefined quotient, right? If we have 0 on the denominator of a rational function, it will be undefined. Moving on to the next page, the concept development, labeled graphing rational functions I. So here we are going to be introduced to a vertical and horizontal asymptote. A vertical asymptote is always in x is equal to a form, and horizontal asymptote is always in y equals a form. A is representing just any number a. And now they ask us to graph the parent function of a rational function, which is 1 over x. So if you did that on your graphing calculators, you'd have these 2 views. On the left, you'd have the graph, and on the right, you'd have the table. And this kind of graph is actually called a hyperbola. One says, notice the error in the table when x is equal to 0. So on the right here, when x is 0, you see the word error for y. And here on the left, it's really hard to see this graph. So I actually did it out on Desmos. So if you hit home, you're going to get this view. And if you scrunch your x and y axes in, you're going to see that no matter where you go. First, let's discuss x values. So as x is going towards positive infinity, doesn't matter how big x gets, it will keep going closer and closer to 0, but will never touch it. The same thing happens in the opposite direction. So as x is going both towards positive and negative infinity, your y value is going towards 0. The opposite occurs as well. So if you're looking at our x values and our y values on our y-axis, well, on these ends of the graph, as our y value is going towards positive infinity, our x value is going towards 0. And the same thing happens up here with our positive y values. As our y is increasing, our x keeps going closer and closer to 0, but if you zoom in, you'll see that it never touches it. So you could see that the ends of the graph extend in opposite directions towards infinity and positive infinity. So if you were to evaluate, which means solve, for when the function is equal to 0, it's asking, well, what would happen? Well, we know we can't have 0 as a denominator, right? So we can't have x as 0, but we know that f of 0 is going to be undefined, or DNE means does not exist. Okay, so undefined or does not exist. And it's asking, well, what does this mean about the domain of our function? A little reminder, our domain is our x values, our range is our y values. And if it's asking about the domain, it's telling us that, well, x cannot be equal to 0. Number 2 on the next page, we're still working with the same function, 1 over x. Here, they're telling us and confirming that there is a vertical asymptote, x equals 0, and a horizontal asymptote, y equals 0. So an asymptote is like a limit. The function is going to reach it, but not touch it. So it's limited to that value, okay? I have it graphed. So here, they're both the asymptotes are right here. The function does not exceed those boundaries. On the next page, number 2, we're still working on the same rational function, 1 over x. So there is, in fact, a vertical asymptote, x equals 0, and a horizontal asymptote at y equals 0. So you don't see these lines, but just because of the behavior of the graph, you can see them, and that's why we put a dashed line, right? It's not inclusive of the graph. It's just the barrier. We're just marking the area where the function is just not surpassing, okay? So it's kind of like a limitation. I've already filled out the table for you. It's asking what's happening to the y values as the x values become either really big or really small. So as you can see, positive x values are on the right side, positive infinity, and then negative infinity, negative x, right, is to the left. So it doesn't matter if x becomes really large or x becomes really small. Either way, it's still going towards 0. So they want now to know what are my a, h, and k values for this function. So my function's 1 over x, and they have this a over x minus h plus k for you over here, just to kind of remind you where to find those values. But here I have 1 as my a value, 0 as my h value, and k as my 0 value. So because this is the same thing as saying 1 over x plus 0, which gave me that h value, plus 0, which is that k value. All right? We already know our vertical and horizontal asymptotes, and now we're being asked about the domain. So the domain is the x values, and it's asking, well, what isn't included? Well, x is not equal to 0 because it's undefined at that point. We can't include it. If I were to put this into interval notation, I would say from negative infinity to 0, union 0 to infinity. So that's going to tell me that it's not inclusive of 0 because that's a parenthesis and not a bracket. Now I want you to know, okay, well, how would you describe the behavior of the function near x is equal to 0? It's talking about the vertical asymptote. So this is where x is equal to 0. So how would you describe this end behavior? Well, your f of x is your fancy way of saying y, okay? And as your y value, as x is going towards 0, it's asking, well, what's happening to your y values, right? So as x is approaching 0, f of x approaches infinity, and as x is approaching 0, it also approaches negative infinity. So if you go to your graph on Desmos, as f of x, which so it's talking about your y values, as x is approaching 0, so it's coming from the right towards here, so it's coming this way, from right to left right now. So as x is approaching 0, they're talking about what are your y values doing. So here, if you look here, it's going to get larger and larger and larger. So your y value gets larger as your x value approaches 0. So your y value is going to be going towards infinity. So your f of x is going towards infinity as x is approaching 0 from the right. If you are coming from the left, from negative infinity, you're going from left to right. So here we have, let me zoom in here, as y gets smaller, so it's going towards negative infinity this way, you can see that this function x is going towards 0 as y is getting smaller. So it's going towards negative infinity. Moving on to the next page, onto Things Get Shifty, part 1. So number 3 is asking us to compare the function 1 over x to 1 over x plus 2. So we have to reestablish our a, h, and k values. So I have a as 1 because I get that from the numerator. X plus 0 is the same thing as x, so I can actually say that 0 is my h value, and I can say that 2 is my k value. So you can use Desmos to graph. I did a little rough sketch for you right here, but I'm also going to use Desmos to compare the two graphs. 1 over x, the orange line, we have negative 1, negative 1. And if you look up here on the green line, we have 1 over x plus 2, but our point is negative 1, 1. So if you look, the y value is actually going up 2 units. See, 1, 2. Jumped 2 units up. The same thing happened here. From 1 to 3, that's 2 units up. Okay? So we're going to say what were the equations of both the vertical and horizontal asymptotes? So now we're going to look at our graph, and we were going to look at our green line and think about where our asymptotes are. So if we're looking at this green line, I can see that it's kind of getting closer and closer towards this line. So maybe y is equal to 2. So y is equal to 2. That would be my horizontal that would be my horizontal asymptote. So let's see if that works. So as you get closer and closer and closer to this value 2, you're going to get closer and closer to it, but you're never going to touch it. So yes, y is equal to 2 is a horizontal asymptote. Now I need to look for my vertical asymptote, which is the up and down, right? So here I'm going to look at my y values, okay? So as x is going towards 0 from the left, I get closer and closer and closer to 0, but I don't touch it. From the right, as x is approaching 0, I get closer and closer and closer to infinity. Oh, sorry, as x is approaching 0, y is going towards positive infinity. So it gets closer and closer and closer, but never touches it. So here, x keeps getting closer and closer and closer to 0. What are the equations of the vertical and horizontal asymptotes? So in this case, we're going to look closely at our graph and see where our lines are kind of going towards. I'm going to zoom in here because it's kind of looking like it's going towards this line, which looks like it will be y has to be equal to 2. So that should be my asymptote. So I'm going to take this and make it into a dashed line, and it does look like that is it. So as 1 over x plus 2 goes towards positive infinity, it gets closer and closer and closer to y is equal to 2, but doesn't reach it. So that is my horizontal asymptote. Now I need to find my vertical asymptote. So x is equal to, let's look at my x values. So if we look here, as we get closer and closer and closer to x equals 0, y is going towards both negative infinity and positive infinity. So that looks like it's going to be my other asymptote, 0. So at x is equal to 0, dashed line, that is my vertical asymptote. And as you can see, you can look at your green function and it will keep going towards that red line, x equals 0, and it will never touch it, but it'll get closer and closer to it. Okay, so those are going to be our asymptotes. How are the horizontal and vertical asymptotes related to the values h and k? Well, we know that our VA is equal to 0, we know our HA is equal to 2, and we know also that our H value is equal to 0 and K value is equal to 2. So this equals this and this equals this. So vertical asymptote and your H value are the same, and your horizontal asymptote and your K value are the same. Now it asks, well, what is the domain? What value is not included? Domain is x values. So because we have one x value that we cannot have, which is x cannot equal 0, our domain, D for domain, colon, because that's going to tell you what your interval is going to be. And I'm going to say from negative infinity to 0, not including 0, union 0 to infinity.